Okay, so I want you to know you did this to yourself. So, did you all hear Christian's original question? Which was sort of, how do you sort whether an example is pathological or not from the beginning? So, one thing you might notice about this one, 2, 3, 5. Cool. What else might you notice?
3, 4, 7.
3, 4, 7?
-4, -2, -6.
Why are you noticing that?
Because the top two lines, are, if you add those together, you get the bottom one.
Yeah, so if I add row 1 and row 2, right, if I add these two equations together, I get not quite this one.
But no, it's like the answers are on the left side, isn't it?
You guys see that? So if I make this into an augmented system, right, I'm going to make my augmented system is going to read 2, 3, -4, augmented by 7, and 3, 4, -2, augmented by 9, and 5, 7, -6, augmented by 20. Then my first step in solving is going to be to try to put a 0 either here or there. I noticed something funky was going on, so I'm going to go for this one because I think it might be a pathological thing. You guys see that?
You would want to go for the 3 first.
I know, I want to go, if I wanted to solve this, I'd try to go for the 3 first. But I noticed something funny, so I'm going to go for this one first. And it doesn't actually matter on this one.
So if you think something's funny, go for the one you think is funny first?
Yeah.
Okay.
Yeah, if you think something's hinky, target the hinky row.
It's worth the time to test it.
Yeah, because if you find out that it's hinky, like if I get 0, 0, 0 and a number, I don't have to keep going at all because the thing has no solutions. You guys see that? If I get 0, 0, 0 and 0, well, then I might have to keep going a little bit. But at least I'll have a row that's easy to deal with because I can just keep writing zeros down the whole time. You guys cool with that? Right, so I want to target the hinky row, which means I'm going to take these two rows, add them together, and see what I get. Okay, so if I add those together, what do I get?
5, 7, -6.
Okay, and 16. So I'm going to take that whole thing, I'm going to subtract that from row 3. Yeah.
Wait, okay, so if 2 intersect but 1 doesn't, then the whole thing has no solutions?
Wait for it. We'll draw the picture in a second. The picture is enlightening here, but I want to show the math first. Okay, so blindly computing, because I'm ignoring good questions, like a jerk. I'm going to leave my first 2 rows alone. And that third row I'm going to replace with
0, 0, 0, 4.
0, 0, 0, 4. Right? Which says there aren't any solutions to this thing. Okay, so I'm going to stop there. No solution, right? You guys see that? I do not have to continue this at all because 0 is never going to be 4, regardless of what x, y, and z are. You guys see that? Okay, so what's the line picture that's happening?
Many options.
These are 3 planes, right? These are 3 planes, apparently. So what's a plane look like? What's a good world analogy of a plane? Whoa. Okay, but I'm going to talk about like running planes together. So I'm going to pick flat things in the room.
Like the whiteboard.
Like the whiteboard, the floor, and the ceiling.
Oh.
Do they all hit someplace together?
No.
No, because the floor and the ceiling don't run into each other anywhere. You guys see that? An example of walls that do hit each other, right? This wall, the floor, and that one. Not this one, not this one. Right? This one, the floor, and the back wall hit each other down in this corner of the room. You guys all see that? So they have a mutual intersection. That's one where I would get a solution, and it would just be the coordinates of that spot. Right? But this thing happened because I had two planes, right, that were a little bit like the floor and the ceiling and the wall, or three planes that were the floor, the ceiling, and the wall. Right, two of them just didn't hit each other.
Or like those three walls, they would all hit each other if they kept going, but not at the same point, right?
Yeah, that's another even weirder one. Yeah, so if you have three walls, this one, that one, and any one of the other three, they all intersect in pairs, but nowhere do the three of them intersect. You guys see that? They kind of make a tube.
Like triangle.
Yeah, the triangle run up and down. Cool. So there's a bunch of different ways for this no solution thing to crop up in 3D. There's even more in 4D. And those are way harder to picture. But it's the same thing, right? These objects just don't hit. Cool? Questions, things on that? The other option with planes, right, is that two of them could be the same plane and the third one could be different. Or all three of them could be the same plane. Those would have like slightly bizarre things happen. But you would get a row of all zeros or maybe two rows of all zeros. Cool with us? Mostly I want you to know that these things exist. I'm not so worried about whether you can find them or not. Okay?